Hi, welcome back to Energy Economics YouTube channel. My name is Godwin. Today's topic is partial differentiation of multivariable functions. Partial differentiation of multivariable functions. Now, we've talked about partial differentiation ordinarily, but what happened was that I happened to kind of maybe forget or something the introductory aspect of partial differentiation because I assumed that it's not something difficult for students to understand. But like I've been saying lately, that it is until you begin to relate with some students that you realize that some things that some other kind of students take for granted are things that might give quite a number of issues, might pose quite a number of difficulties for other students. Okay, so what is partial differentiation? I'm just the definition on the board. Partial differentiation is a process of finding the derivative of a multivariable equation with respect to one variable while holding the other variable constant. So what's a multivariable equation? So I think that's already easy to know from the word itself. A multivariable equation is an equation that has many variables. Alright, that has many variables. So now that is why we need partial differentiation. That's why we need to understand partial differentiation. In the other kind of differentiation that we've been doing, we only have an independent variable and a dependent variable. So where we kind of differentiate the dependent variable with respect to the independent variable. But in multivariable functions, you have more than one independent variable. So that's why it's called a multivariable function or a multivariable equation. You have more than one independent variable. So when we want to differentiate, we can differentiate one variable while holding the other variable constant. So here we are looking at we are looking at the changes in the dependent variable that will occur as one of the independent variables in an equation is changing. Alright, the changes in the degree of changes in the dependent variable as one of the independent variable is changing. So if I'm saying one of, so that means I'm assuming that other independent variables are all constant. So that is just what partial differentiation is all about. Yeah, so there's an example on the board. So where y, which is the dependent variable, is a function of x and z. So you have y equals 6x cubed, then z. Alright, so if you want to differentiate y now with respect to z, so we can write it like this. Partial derivative is a slanted d. A slanted d, please. When you write a normal d, like a straight line d, so that's talking about total derivative and what have you. So it's a slanted d. So you have the y, the x. So the y dx is going to be equal to, you differentiate this with respect to x, that's the meaning. You have 3 into bracket 6, x, 3 minus 1, then z. You're not touching z at all, so you're assuming z is like a constant or something. Alright, so 3 times 6 is 18x squared z. Sorry, z is not a constant, but you're not just touching it, right? So if we were to differentiate a constant, it becomes 0. So z is not a constant. So the y dx is simply this. Now, if we were to differentiate with respect to z, that would be a partial derivative, that's the y, the z. Okay, the y, the z, and that is just going to be that's just going to give us 6x cubed, simply because the power of z here is 1. So that's just it. So this is all about partial. No, not this is all about partial derivative though. This is kind of what partial derivative is all about. Alright, so something like this. Now, there are types of partial derivatives that you could be asked a number of questions on partial derivatives. So number one, you have the first order partial derivative, WRT. I wrote WRT on the board. So what that simply means is with respect to. Okay, so you have first order partial derivatives with respect to a particular variable, that is with respect to a particular independent variable. Then you have second order partial derivative. You could have third order, you could have fourth order. It depends on whatever it is that it is to be used for, the function is to be used for, or the differentiation of the function is to be used for. Then we also have the cross partial derivatives. So we are going to treat the three of them one after the other. Like I said, you could have third order, fourth order, whatever it is. But here, this is just what we are concentrating on. I have already told you that you could express your partial derivatives this way, the y dx, okay. So another way that you could express your partial derivative is now here we are given y equals 6s cubed z. Alright, so if we say yx So yx is just telling us to differentiate y with respect to x. Alright, so yx is going to give us this answer back, 18 squared z. You have 18 squared z. And if you have yz, that's going to give us differentiating y with respect to z, which is this. That's going to give us 6s cubed. So it depends. So in some textbooks we have z being a function of maybe x and y. So if you're asking for zx, so you have to differentiate z, function z with respect to x. If you have zy as a differentiate function y. So you are going to do it here anyway. Alright, so in this particular question, so let us look for the first order partial derivative. Now, we are going to be looking for first order partial derivative with respect to x. We look for the first order partial derivative with respect to y. The same thing for second order derivative, and then we go into the cross partial. The cross partial, we are going to see what it's going to be. So it's easy. So here, first order partial derivative with respect to x is zx. First order partial derivative with respect to x is zx. And that's simply going to give us 90x squared y4. Alright, 90x squared y4. So that's about that. Now, what about the first order partial derivative? Okay, let me do the second order partial derivative. So here you have zxx, right? So you've differentiated once, you are differentiating this again. Alright, so you are differentiating it 2 times with respect to x. So here, what we are going to differentiate now is this guy. So that's going to give us 180x y raised to power 4. You're not touching y. Alright, 180x y raised to power 4. How about the first order partial derivative with respect to y? That's zy, okay? And that's this is y here. So the power comes here. So you have 120 x3 y3. So that's all about that. Then what about the second order partial derivative with respect to y? Zyy. So that's going to give us 3 comes here. So you have 360x cubed y squared. Now I'm not teaching as if I'm putting a baby, because I already assume that you know basic differentiation. So the way this guy is becoming 360, the one is becoming 120, I don't think it's going to be a problem for you. Okay, you cannot be starting your calculus classes with partial derivatives. Alright, so you must have had the understanding of normal derivatives before this one. Alright, so that's all about that. Okay, so from there, let us then move to the cross partial. Now, cross partial is basically you differentiating with respect to a variable at first, and then differentiating what the function you have with respect to another variable. Okay, so here we have zx, right? So if we were to make cross partial here, so since zx is this, a cross partial will be zxy. Okay, so now we are differentiating zx with respect to y. Okay, we are differentiating this z with respect to y. So that's going to give us 360, okay, s squared y cubed. That's all. That's all. Now let's look at zyx as well. So it's just grammar, just speak English. Now so we have zy here already. So let us differentiate zy with respect to x. Okay, so now that we're differentiating with respect to x, we are having 360. We are differentiating with respect to x now. 360 s squared y cubed. So there's something I want us to know. If you look at the answers, your zxy is the same like your zyx. Alright? Zxy is the same as your z, but because look at the answer, 360 s squared, whatever, the same thing over there. So that brings an important that gives us an important observation in doing something. So now if you were to multiply this cross partial zxy times zyx, now basically because they are the same thing, alright, they are the same thing here and here. So this is the same thing as saying zxy squared. Alright, or you just saying zyx squared. So you can choose the two. Now because we are going to be using this thing in our next class, we'll talk about the optimization of multivariable functions. Alright, so we'll be needing the understanding of that. Okay, now talking about denotions again, how do we denote? Then we could denote this way, then we could also use this our normal d, partial derivative, whatever. Because I don't know what textbook you might be reading, and I want you to understand this stuff, so regardless of the textbook that you are using. So here, if you were, let's say we started from here, so you have zx here. So if we were to do a partial derivative with respect to okay, well, we understand already that zx is this, right? Zx is this, zx is the same thing as I'm just showing you mathematical notations now. So Zx is the same thing as partial Z partial X. Alright. Now Zx is the same as D squared Z partial X squared. You understand? So tell us that differentiating the second time. So this is how you do it. Now, how about the partial derivative? So you have how to express zxy in this form. Alright, so we do that. Say instead of something like okay, let me say something like dz. You differentiated. So what's this mean? What this mean? Okay, yeah. For you to have zxy, you have the x, the dz, the y. Alright, z dy, you have the z dy of into brackets dz dx. So what this is saying is that we are taking, but properly should be written as d dy. Okay, so what this simply means that we are taking a d dy of something that you differentiated before, the dz dx. That is, you are differentiating this person with respect to this person. Okay, now let me use an example so that you don't get confused. So d dy, so you have d the y into bracket. Look at this is z, this is a zx here. Alright, so 90s squared y 4. So like 90 s squared y 4. So you are differentiating this with respect to y. So that's what it means. That's what it means. So when you do that, you'll be having 360 x squared y3, 360 x squared y3. So if you look at it, what you had initially was zx. This is your zx, right? Okay, this is your zx. Okay, now that you are differentiating zx with respect to y, what you're having now is your zxy. Okay, and differentiating zx with respect to y. So just know how to write these things. Or if you are not able to write them, if you were to write them like conveniently the way you want, just choose the one as better. That you think you are not going to like mix up. I think this guy writing this in this way is kind of really good. But regardless of the book you are reading, so I just want you to like know to understand these things, when you are reading these notations and what I'm doing. Okay, so that's about that. Now, how about, this video is not going to be a long video, it's an introductory video. Then the big boy is the one after this video, not the big boy, something like a little bit of something. Alright, so here, what is the value of zxy when x is 3 and y is 4? I think that's what I have here. When x is 3 and y is 4. Okay, when x equals 3 and y equals 4. So zxy, okay, which is 360 s squared y3, 360 s squared y3 will then give us 360. What is x? X is 3 squared and y is 4 cubed. Okay, so by the time we do that, we have 360 multiplied by 9 times 64, and that will give you 207,360. 207,360. I hope I'm not wrong. So that's it. I think we are done with this video already. We are done with this particular class. So the next thing is for me to give you an assignment. Okay, so your assignment is just this. Okay. Okay, don't even rest it there. The assignment is already on the board. So if z is 15 as squared plus 20x cubed y squared minus 4xy over 5a squared plus 60. So A, find all the first and second order partial derivatives. So look at it, you have two independent variables in this question. So find all the first, and so you have zx, whatever like that. Now for B, you have to find all the cross partial derivatives. So recall that you have three independent variables here. So you have to find the first, the cross partial derivative. You should be having maybe 9 cross partial derivatives, something like that. So you have the ZA already. So you have the ZAX, the ZAY. Then you move to like ZX, something like that. ZXA, ZXY, and so on and so forth. So you're able to get all your cross partial derivatives. So that's all about that. In the next class, I'll be talking about optimization of multivariable functions, and from there, you're going to have a really nice time. See you in the next video. Thank you for